Welcome everyone to the last episode of season 2 of Across the Opti-Verse. This is probably going to be my favorite episode. It's the first time we're interviewing someone not from Optinum, someone external, someone with a lot of experience. And I've been one of the coolest pre-episode chats I've had discussing what we would talk about. I'm really excited to introduce Steve Miller from MathWorks. I'll give him time to introduce himself, but I think one of the key things that we're going to just talk about is, the growth and the journey we come through in design and simulation. I'm been talking about having an external guest for about a year on this podcast, and we finally got one. And Steve, thank you very much for joining us today. We're looking forward to it. I think before we get into the meat of the episode, maybe if you could paint us a picture about who you are, how'd you get here, and anything else you want to say.
Sure. So I've been at MathWorks now for a little over 20 years. And I've had the opportunity to do quite a few things while I was there. I'm originally from the United States, and when I moved over to Germany, I wasn't yet at MathWorks, so I worked at a few different automotive companies and then joined MathWorks directly in that office. So I've been lucky enough to have the chance to work with a few different types of companies doing different types of, working on different types of systems, such as cars and planes and even space stuff. And had a chance to do some good technical things as well as some non-technical things. And both of those really give you different perspectives on how engineers work, what challenges they face, both in trying to solve a specific problem and then also helping their company or helping develop a more complex system on a longer journey.
Yeah, that'd be amazing. Yeah, I'm sure you could tell everyone listening at the start how excited I am. I got a bit nervous, spoke a bit fast, but this is exactly what these things are for. I think, let's jump in right into the episode. Okay, Steve, thank you. Yeah, as I said, thank you so much for joining us. I think before we get into the meat of the episode, I mean, you're an engineer. You said you're from the States. How did your engineering journey start, really?
So when I was in college, I studied mechanical engineering, and that was a fairly easy choice for me because I'd always been, when I was like in high school and even younger, kind of focused on playing with mechanical things. I did have a period of time when I was considering doing materials science, but the challenge I found there was most of the problems I was trying to solve were things I couldn't see.
Yeah.
I couldn't, maybe you could touch it or infer what was there, but mechanical engineering really spoke to me because I could actually see and intuit the things I was trying to solve. The end of my college career, I took several controls courses, and I found that completely fascinating because it was essentially giving smarts to a device that you might consider to be completely inanimate.
Yeah.
And then my first job right out of college was working for an automotive company, and I got to design anti-lock braking systems. And that was exactly sort of two pieces that fit together from what I found I was interested in high school and college is a mechanical design, a mechanical system, in this case, a car, and then working with adapting, tuning the smarts of the system that's trying to keep the driver safe as you're driving on uneven surfaces, ice, snow, that kind of thing. And so that period of time where I was working, like sitting in the car, driving it around on test tracks, adjusting the control code was extremely tangible way to experience all of the theoretical and engineering stuff that I had studied in college. And then from there, I worked in the car for a while, but I always found myself taking the data that I'd recorded from the car, analyzing it offline in MATLAB, and through a few other detours, I actually ended up coming to work for MathWorks. And it was really sort of, again, the sum total of my experiences told me, this is actually the perfect place for you to be because it really ties together all the things that you really liked from the college career and the first experiences out in industry.
Amazing. I mean, yeah, you spoke about your first job testing the cars. I mean, that's, and I know this because we've spoken previously, you said that was very hands-on process, not a lot of simulation. When did you start seeing simulation take more of a prevalent role in your career and just in general in industry?
Yeah, I mean, back when I started, they weren't really doing much simulation at all. A lot of it was literally just go out in the car, perform a series of tests, and then maybe just stare at the data in the car and try and figure out what was going on.
Yeah.
And what ended up happening was there would be a few gurus in the group. Like you would call them over to look at the trace, and they knew enough about the algorithm to say, this is the state you're in, this is the problem you're having, these are the parameters to adjust. But those were the only people who could actually do that just by looking at a plot on the screen. So I was like, to reach that level of experience is going to take me years. I can't wait that long. So I would take all the data back to my desk and start analyzing it in MATLAB to try and figure out what patterns should I be looking for to recognize that the algorithm is having an issue or getting into a bad state. But even that was still data analysis and sort of reverse engineering algorithms to some degree. It wasn't necessarily modeling and simulation.
Yes.
And that's when I felt like most of my time was trying to find problems, not actually solve them. And that's at the point when I actually started to like think, as much as I love this job, and I'm like, I don't think I'm ever going to have a cooler job than being a test driver. I'm like, I really don't want to be only finding problems and just kind of patching. I want to actually, I want to solve the problems.
Yeah.
And that's when I was like, okay, the place to really solve these things is not sitting in the car stuck in a snowdrift. The place to be solving these is back at my desk using a virtual test where I can try solutions and figure out, did this actually improve the situation? Is this a solution I can trust not in the one test that I just ran? Can I trust this solution in every case that I or any other driver is likely to hit?
Yeah. I mean, that talks about the ability to iterate and innovate through your designs quickly, rather than the process of find the issue, then fix the issue, then test and find another issue, then fix the issue. As you said, you can work through. That's brilliant. And now, obviously now working in simulation for a large portion of your career at MathWorks, you've gained the experience and seen the benefits of what simulation software can do. I think a question I want to ask is, how do you see, what role do you see the engineer taking, and what role do you see the simulation software taking in these processes?
It's a good question. I mean, we are often armed with simulation tools, and the simulation tool can do pretty much anything. I mean, there's a lot of simulation tools that are out there. They each have their own specialties and weaknesses. But at the end of the day, it's kind of a generic tool that can only do what the engineer tells it to do.
Yes.
So I mean, a large part of my time, at least early on, when working with customers that I interact with, is to first interview them and find out, okay, what question are you actually trying to solve? Because that gives information as to how the model should be constructed, what data are we going to need, and what tests are we going to run. And then another phase of the interrogation is, okay, how much detail do you actually need, and how many types of tests do we need to run to actually get the answer to that question? So I mean, as far as the role of the simulation tool, again, in the right hands, it can answer any question.
Yeah.
The role of the engineer, though, is to make sure that we construct a model that can answer the exact question we need answered, and that it can answer that question in a very efficient way so that we can extract the most value out of the model. It's not all that useful if we construct a model that can give me the perfect answer, but it takes 2 weeks to produce the answer. That's, again, there are values for those types of simulations. But if you're trying to find a robust solution where you need to test many conditions or many different variations, parameters, you need to make sure the model is crafted to tackle that type of problem.
Yeah, I mean, that's exactly it.
Yeah.
That's so cool. I think now I want to just take a step back and talk about how everyone's backgrounds shape design. When we spoke earlier, talking about this episode, one of the questions I just came flying in was like, what mistakes have you made and how have you learned from them? But then you mentioned something that I want to actually talk to, is that you said, no matter how much experience you have and how many things you've seen, every time you go into something, you see a new design and a new way to do something. And you said, it all depends on our background and how that shaped us. I want to talk about that.
Sure.
How has your background shaped how you approach design and modeling today?
I mean, most of at least my initial background was focused on mechanical design. And I would say the later control courses gave sort of a new perspective on what the mechanical designs would be forced to endure, what the mechanical designs would experience, and also how much more the design can do. I mean, early on in mechanical engineering courses, you focus on static design. And so that's really just saying, all right, what's going to happen to this bridge or this chair or whatever when it is sitting still, experiencing a normal amount of load? I mean, those calculations are immensely important in pretty much any type of mechanical design. But it was once I started to get into control design and seeing more dynamic analysis, I said, okay, there's a lot more to this than simply looking at the steady state situation. By looking at it from control's perspective, it was like, well, how quickly can it respond?
Yeah.
And the worst case scenario will not be when everything is sitting still. The worst case scenario is actually going to be when it's undergoing a rapid transition. I mean, in a car, it'd be a rapid lane change, impact, anything like this. So by taking the controls courses and being exposed to other types of engineering design that involve actuators and software and things, it gave me a different point of view on the mechanical design that I was doing. Again, the static analysis, it's important, but you need to think about all the conditions that's going to experience. And then going on into graduate school and then like working with a range of different customers, a vehicle that drives on a road is going to experience a certain range of things. But a vehicle that goes off-road, potentially not even on off-road being bumps, but also being soft soil, mud, grass, snow, is going to experience another range of things. And that, again, just broadens the horizon of you can't just think about your system in the perfect, ideal, simple scenario.
Yeah.
You have to also recognize people are going to abuse these systems and use them for things that they weren't really designed for. And you want to make sure that they're not going to get stuck somewhere or that the system is going to fail in a spectacular way and hurt someone potentially.
Yeah, I mean, exactly that. I mean, that's also, it's like when you start off as a junior, even as a graduate into your first job, you get a project, you're so like isolated and tunnel vision to solve problem one. But the more senior you get, the more you engage with clients, you get to a position where you can solve a full pipeline of solutions. So I wanted to talk about that. Like, I mean, how did that shift happen for you from solving one problem as a out of college graduate to now solving the full pipeline? I mean, how does that mindset change?
I mean, when I've worked on things in the past, I'm like, I'm pretty skilled. I know how to. I've done some good work in the past, and you can be quite proud of the things that you've done. But what I've found as I've been involved in larger and larger teams is that it's very important not only to capitalize on the experience of all the other people that are in the team. It's also so to get them to contribute to the technical solution. It's also important to use their experiences to make sure that you're considering everything that you need to consider, and that you haven't forgotten something as far as the overall design is concerned. I mean, one particular example. I work with companies that work on agricultural machines, and it would be there's two major systems in there. One is the propulsion system, which will drive the tractor, and then there's the implement that could be on the back, it could be on the front, it could be a bucket, it could be a grapple. And with that, there's software that controls it. There's actuators that need to move things around, and so there are actually quite a team of people working on this tractor. So I would interact primarily with the guy who was involved with the suspension and the steering, but periodically he would say, to answer this question completely, I've got to go talk to the implement guys. And I'm like, but you're the tractor guys. Like, tractor is not a tractor. A tractor is like a complex machine with multiple systems integrated. And listening to someone who everyone said he's the expert, to listen to him say, I got to go talk to these other experts. I'm like, okay, it takes a real team of engineers to make sure you've thought about and captured everything you need to think about before you make a complete design decision.
I mean, that's exactly it. And it talks to what I want to kind of ask you next. I mean, I was the same. As out of varsity, I was like, I'm an engineer. I only want to work in engineering. I mean, theoretically, you are still working in engineering, but in a very different role than I would say what the traditional engineer pictures out of university. How did that happen? What pulled you towards the current world you're in?
I mean, when I started at MathWorks, before I came to MathWorks, originally I was basically a software engineer doing anti-lock braking systems, but I never studied software design, so that was kind of interesting. But then the next role that I was in at the company I followed on after that, I was a consultant doing pure mechanical simulation with some controls on the side. And solving, again, specific problems defined by a customer, and I had a specific deliverable. When I hired into MathWorks, I was actually a sales engineer. So this was another step in the progression where I had been solving targeted, specific technical problems. Now I was not necessarily solving the problems, but I was helping engineers understand the problem they were going after as an application engineer or a technical sales engineer, and attempting to communicate the value of what we had to provide to them. And it was a little bit strange. Like, my title still had engineer in it, but I was okay. I was okay with that, even though I was working more with salespeople than developers. I'm like, okay, I could still, psychologically live with this. But then came the opportunity for me to become a product marketing manager. And I was like, oh man, my title is not going to have engineer in it anymore. I'm not sure I'm okay with this. But it was at that time, it was a good opportunity for me to take, and I took it. And one thing I actually didn't realize until that transition to MathWorks was that I actually really like telling stories. And a lot of times when I'm preparing materials in my current role, I'm arming the technical sales staff with materials that they can use to show the value that our solutions provide. And an important part of producing those materials is making sure that they're very easy to understand, that you don't get bogged down in the details of, what type of gear were you using, or what type of pump. It's more about using this type of model, you can answer this type of question. And I found that in taking those materials and preparing them in such a way to tell a complete story, I actually a lot of times would find technical gaps in the example. And so by looking at this from another perspective, not just calculating the exact gear ratio to make it the most efficient, but showing this is how how you create the model in the first place, and how you evolve the model to include all the effects that you need, and then how you streamline the model to calculate all the answers you're going to care about. By making sure I could tell that entire story, that was actually immensely satisfying. And it's part of the reason I'm still in this role. I didn't become so disenchanted with being in marketing that I was like, oh no, this is not my roots. I actually found that in addition to having a good technical expertise, understanding the entire workflow and how making sure that the model can support that workflow, and that an engineer or a potential customer can understand that is extremely valuable. It contributes as well to a technical understanding of the application being explored.
Exactly that. I mean, it talks to this common theme. To work in marketing, you have to understand the problems of the market, what the market needs. So you have to keep up with the technical kind of know-how and innovation coming into the market. How do you stay connected to the market?
I mean, there are sort of high-level ways to stay connected to the market. I mean, there's all kinds of reports that are produced. I mean, I'm sure you get pinged by LinkedIn like every 5 minutes with the latest whatever survey or somebody's recent achievement. And that stuff is valuable, especially if you follow specific people. There are certain people who I trust. Like, if they post something, I'm going to look at it because I know they've been their posts have been valuable in the past. They've managed to predict things, and they're easy to understand. With the whole, large language model thing, if it's an area I've never experienced before, a lot of times just, doing a search and relying on ChatGPT or other large language models, you can get a pretty good summary. That's another way to, at least for new areas, to say, is this something that I'm interested in, that I'm related to? But I've found that the best way for me to stay connected to what's going on is to have deeper technical engagements with customers who are kind of pushing the envelope. And if when I interact with a lot of customers, and when I find the ones that I feel like, they have something to offer and I have something to offer them, and we can set up something where we communicate regularly, where they illustrate for me challenges that they have, and then I will take that information and then show them, here's the way I would solve that problem. Do you think this would be useful for you? And getting that kind of live feedback, that's really the best way to make sure that not only do I understand not necessarily what the overall trend is, but understanding sort of a specific instance of that trend, and what are the realistic constraints of, what information do they have, do they not have, what portion of the design can they adjust, not adjust. That's a much more tangible way of making sure that I understand what this high level trend that I may be reading about, how does that actually affect the way engineers work? By working with these technical experts in like sort of live, real-time back and forth, that's really, I think, the best way to make sure I understand what's going on in the market.
Yeah. Look, I can say I follow you on LinkedIn, so I trust anything you post. I read it often. I think we're going to close off now. I think there's two questions I want to ask.
Sure.
The first one is, you've been in South Africa for a few days now, and I know you've worked with some of the academic institutions in South Africa prior to coming here. How do you see the South African market differ to the rest of the world?
I didn't really have much of an expectation before I came. I will say though that I do have a number of colleagues from South Africa that I interact with both in Germany and the United States. And so I would say I had a pretty high expectation for what I would see because they're among the colleagues I trust the most.
Yeah.
But then, there are the people who these are people who work at my company. So obviously there's some kind of bias there. The companies that I've managed to visit while I'm here, I guess one difference that I've noticed is in all the meetings I've been to, everybody in the room contributed to the conversation in a substantial way. And that was not something I always see. Typically, if there's a meeting with more than 3 or 4 people, there are a few junior people who might hold themselves back. But that didn't happen here. Pretty much every meeting I've been in, it really didn't matter whether it was the manager or if it was a younger guy. Everybody had a significant contribution to the conversation, which I really liked. The other aspect that I've seen, I've managed to interact with a few different commercial companies and a few different research areas, research institutions, and the range of topics is immense, and the depth of understanding has been quite immense. So I've been very impressed with what I've seen so far.
That's great to hear. I mean, there's a massive push from academic and industry to continue the innovation, and that's awesome to hear. I mean, now we're going to go outside of anything technical to close us off. You've been here for 3. What are you looking forward to, or what have outside of work in South Africa?
Yeah, it's funny. And before I came here, I've been to Africa before, but not South Africa. And I was kind of hoping that I would have a bit of time to explore, do a little bit of touristy or sightseeing and things. I was lucky enough to arrive like a couple days early, so I did make it to Pilanesberg.
Okay.
And we were lucky enough to see quite a few animals, including a leopard, which I hear is quite rare.
Yes, yeah, very much.
So we were very fortunate in that sense. So that was part of the first weekend.
Yeah.
And then the second weekend we'll be down in Cape Town. So I expect to do a fantastic hike while I'm there.
Oh yeah, amazing.
And I've been promised some good wine while I'm down there. So there's quite a few things that I'm still looking forward to. But I will say, the entire journey, even just sitting in the car and seeing the beautiful countryside, interacting with both the colleagues at Optimum and the customers, has been a terrific experience. So I'm going to be sad when the 2 weeks are over, but I'm immensely enjoying the time here.
Oh, awesome. That's so exciting to hear. And look, Steve, I can just say from us at Optimum and Across the Opti-Verse, thank you very much for being our first external guest, first international guest, first everything. I mean, as I said, we've spoken about this. We are so chuffed, and this conversation has been great.
Perfect.
I hope to engage with you more in the future.
For sure.
And if you're ever in South Africa again, we'll definitely have a follow-up one.
Sounds good.
Yeah. To all our listeners, thank you very much. This would be the close-off for season 2. I think there's no better episode to close us off. If you have any questions or want to reach out, you can reach out to myself or Michelle or to Steve. We'd love to have conversations around simulation modeling and everything. This is what it's about, and this is what we want to do. So Steve, thank you so much. Really appreciate it.
My pleasure. Thank you.
Okay, cool. I don't know if I can say welcome back, but welcome back to, it's kind of the bonus episode for season 2, a close off of the year, of the season. We just want to say this year it started off slow, but we eventually powered through. We got it back when Optimum asked me to come back to host. It was an easy decision after the plans we had made at the end of last year didn't kind of work out. But with the help of Michelle, we were able to get it up running again. So Michelle, thank you.
Yeah, super chuffed about that. It was a late start, but I'm super glad that we got the momentum going and we had some keen people that we interviewed. It was really, really exciting. The episode we just recorded now, I think would be, I'm looking so forward to that coming out. So,
yeah. I mean, the exciting bit about it is last year we spoke before I left Optimum about getting someone not from Optimum to be part of this podcast. And when we did that this year,
finally did it.
We did it.
Double whammy. It was amazing. Yeah. International person and first.
Exactly.
Incredible.
Very cool.
Yeah.
And I mean, all the other episodes we got to speak to Prof. Harley, who's got a lot of academic experience versus what we talk about in industry. And she really helped us connect that there. I mean, I remember talking to Toby and his stories about AI, the history of AI that I'd, never think in my life I would have had a conversation with someone. So it's
I definitely feel like it's been a series of storytelling. I feel like each sort of episode has touched on similar things.
Yes.
With that thread of industry, academia, and a whole bunch of passion coming through. It was really, really cool.
I think that's what this is about. I mean, season 3 is going to come next year. We still need to discuss
Yes.
scale their big ideas, and we're looking
Yeah.
forward to implementing that. Hopefully we can get more international guests and
That'll be
more
great.
external guests.
So anyone listening to this, if you're keen,
please reach out to us. We
Yeah.
really want to interview you. I think, yeah, as we've had as the constant theme, the podcast is growing.
getting more confident in it.
Yeah.
Yeah.
Learning more things. We've made a few more mistakes,
which is great. Just don't make them again.
But I mean, yeah, I'm looking forward to what 2026 has in store for Across the Opti-Verse, and as an external for Optinum, to see, you know, I get to see from the outside in. It's always nice walking back in here and seeing faces I, you know, worked with for so long. So yeah, Michelle, I mean, thank you for all your help.
Thank you. Yeah, it's been a great year.
Yeah.
Can't believe it's gone so fast, but looking forward to next year.
Yeah.
And yes.
Yeah. So to close with that, enjoy your holiday season, everyone. Particularly those traveling. Travel safe. And when you come back with cool ideas and questions for us, because we would love to, you know, be a part of that journey. Cool.
Great. See you guys soon.
Yep. Thanks.